Whenever there is any earthquake occurring anywhere in the world, the press and in turn the people, they want to know what's the size of the earthquake, where it has occurred, that is the location, and what was the damage due to that. Now these three questions, they are answered by the seismologist using the recordings, using the observations, and they have to be answered at once. First, the location. The location is given in terms of the name of the place and more precisely the latitude and the longitude of the place along with the depth. The next is the origin time when the earthquake has occurred. The rest inquiries from the press or from the people are what was the size and what was the damage. The size is generally given in terms of magnitude and the damage is given in terms of intensity. And these two terms, they are used by the media and the people interchangeably. This is not the case. The case is that magnitude is different and intensity is basically the observation. So, in this episode, we will see what is the magnitude of the earthquake and the intensity of the earthquake. So, let us see first what is the magnitude of the earthquake. The magnitude of most earthquakes are measured on the Richter scale. Richter scale was developed by Charles F. Richter in 1934. The magnitude is calculated based on the amplitude recorded on Wood-Anderson seismograph at 100 kilometers. Let us see the definition of magnitude, the Richter magnitude. Definition wise, Richter magnitude is the logarithmic of the amplitude recorded by Wood-Anderson seismograph at 100 kilometers. Let us take one example. Let the amplitude recorded by Wood-Anderson seismograph be 1 micron at 100 kilometers. It means the magnitude will be 0 because m is log of A max and A max here is 1 microns. In practice, we cannot measure the amplitude in microns. So, the Richter magnitude is defined as the logarithmic of the amplitude, maximum amplitude on the record in mm, and then a term is added which is given in the table. Here you see that at 100 kilometers it is 3. So, 1 micron earlier recorded is now 0.001 millimeter, and that means at 100 kilometers the value as you see in table is 3. So, the magnitude will be 0. Different magnitude scales were developed later, but they were all calibrated to the Richter's scale. The magnitude scales developed were basically the body wave magnitude, the surface wave magnitude, the moment magnitude, and now most of the earthquakes, they are given in moment magnitude scale. It is commonly known and well understood that the major earthquakes, they have done more damages than the smaller one. The damage potential of different earthquakes is varying and reduces with increasing distance from every earthquake. It has therefore been found useful to systematically study the damage during past earthquakes even when no scientific studies were undertaken and no instrumental data were obtained. It is to be emphasized here that importance of earthquake observations has not diminished with the availability of the sophisticated instrumentation, and the earthquake's effects are studied even now, since they are important effects and they give us important information. Now, let us see what is actually the earthquake intensity is. Earthquake intensity is defined as the strength of seismic shaking at a given location. Whereas an earthquake has got one magnitude, it may be assigned many intensities, of course at different locations, since the damage at different locations will be different. To understand the difference in the magnitude and the intensity, let us demonstrate it by one of the examples of a table lamp. Now, this lamp is having one bulb of 100 watts. The points A, B, C, D, E are going away from the lamp. Now, the magnitude can be understood as the wattage of the lamp, which will remain same for this, but the intensity of light, which is different at point A, B and C, and it is decreasing with distance, can be understood to be the intensity of the earthquake. So, we see that the intensity is the qualitative measure of damage at a point depending on the damage to the built environment, the reaction of human beings and the general observations. A good intensity scale should trace the intensity variation in different locations during a given earthquake, for different earthquake in different locations and for different locations and the same earthquake. To develop intensity scale, there are few points. Let us see what are the points to develop a good intensity scale. Each higher grade of intensity scale should represent approximately equal increments in the amount of damage. Mechanical effects rather than personal impressions should be used to assess the intensity for different grades. To avoid ambiguity, there should not be many alternative tests for each grade, and those included should be commonly observable. The separation of adjoining grades should be sufficient to allow an observer of ordinary intelligence to distinguish clearly between the tests for each grade. Now, let us see the historical development of intensity scales. Towards the end of the 19th century, a need was recognized to scientifically study the macroseismic effects. Macroseismic effects means those effects which cause the damage, which are due to the damaging earthquakes. So, these effects were supposed to be studied on the human beings and the built environment. M.S. de Rossi of Italy and F.A. Forel of Switzerland combined their efforts in 1883 to create a numerical scale, the Rossi-Forel scale, which we used sometimes today even, was developed, and then the intensity was divided into 10 different scales. Each level or step in an intensity scale provides a primarily qualitative description of earthquake effects. These descriptions may include human perceptions, such as being awakened from sleep, being unable to stand, or even being subjected to general panic. The effects on buildings and constructions, such as damage to chimneys, collapse of adobe houses, or loss of service of underground pipelines, and then the effect on natural surroundings, how the effect was there on the landforms. Maybe some cracks have developed during the earthquake, some fissures may have developed. Then later, since these effects were having a large range. Scales were developed on 12 points. In southern Europe, the 12-point Mercalli-Cancani-Seeberg intensity scale, which is known as MCS, is used. It relies in part on determining intensity level by the percentage of buildings damages. This has proven useful in a country where there is a relatively uniform type and quality of village construction. And this is not the case for Indian, because here the construction type is very heterogeneous. You will find the mud adobe houses, and then in the neighborhood you will find a well designed engineered building. So, for this another scale was used, which is known as modified Mercalli scale. The intensity scale currently used in United States and India is the modified Mercalli intensity scale. The scale, as modified and revised by Wood and Newman in 1931, is the basis upon which individual scientists, state and federal agencies evaluate past and present earthquake effects. Similar to MSK and MCS scales, it consists of 12 intensity levels ranging from 1 to 12. In intensity scales, Roman numerals are used. If you see in the newspapers, the reports, the magnitude is always given in decimals, but the intensity is given in Roman numerals, intensity 8, 9, 10. Now, before we go for the intensity scale which is used nowadays, let us first discuss about the effects of the earthquake. The effects, they are classified in two categories: the primary effects and the secondary effects of earthquakes. The primary effects are those effects which are due to the source itself. The secondary effects are because of the propagation of waves. Now, you know what is seismogram? Seismogram is a record of earthquake. Now, this record is because of the propagation of waves. So, seismogram, as you see here, is the best known example of secondary effect. These secondary effects are again divided into two categories: the secondary transient and the secondary permanent. Now, let us see these effects on terrain. On terrain, the primary effect may be regional warping, scarps, offsets, fissures, or elevation or depression of ground or of the coast. The secondary effects, the transient one, are visible waves. You know that the wavelength and the amplitude of seismic waves is such that you can even see them traveling on the surface. So, that is the transient one. The secondary permanent effects are landslides, secondary fissures, sand craters, raising of pores and piles. Now, let us see the effect of earthquakes on underground water. The primary effect may be damming, waterfalls, diversions, sag ponds, or changes in the wells. For example, if a source is passing through a well having sweet water or the potable water, now due to the displacement from the source of water in the well may change and you may get saline water. Many a times we see that the property of the water in the wells is changed. Now, let us see what are the secondary effects. Changes in well levels and earthquake fountains are some of the secondary transient effect, and you know that on water there may be no secondary permanent effect. Now let us see the effects on the construction. This is one of the most important effect of earthquake on which the intensity scale is based on. The primary effect may consist of offsets or distractions or damage in the buildings, bridges, pipelines, railways, fences, roads, ditches, etc. The secondary permanent effect is the one which we found when we go for the damage survey, because the primary effect will be very local, which is there due to the source only, but the secondary permanent effect is found in a very wide area if it is a damaging earthquake. Like for Bhuj, the damage was found as far as 800 kilometers away from the source. So, this all area has to be studied for the damages, and then the intensities are assigned based on the damages. So, let us see what are the secondary permanent effects on buildings. Most ordinary damage is done to the buildings, chimneys, windows or the plasters. What are the secondary transient effects? They are creaking of frames, swaying of bridges and tall structures. Now, these are on the built environment. Let us see the effect of earthquakes on loose objects. You know that the primary effects are very local and there may not be any primary effect on the loose objects. The secondary permanent effect of earthquakes on loose objects may be the displacement, including the apparent rotation, overturning, fall, projection, horizontal or vertical. Then the transient secondary effect may be rocking, swinging, shaking, rattling. So, these effects we have seen on terrain, underground water, surface water, loose objects. But most interesting effects when you go for the damage survey and interview the people are the miscellaneous effects. There are no primary miscellaneous effects, and the miscellaneous transient effects are the most important, because these are the effects which the people will tell you while you are interviewing them to assign the intensity at a place. The secondary transient effects are nausea, fright, panic, sleepers are awakened, animals are disturbed, birds are disturbed, trees are shaken, bells they rung, automobiles they are disturbed. Sometimes we also hear the noises or the flashes of lights. Many a times scientific reasons are given for them, but in some of the earthquakes we can see and we can hear the people talking about these effects. The secondary permanent effect in miscellaneous category are clocks they stop or change the rate, glaciers affected, fishes killed, cable breaks. These are the effects of the earthquakes on which observations are made and then the intensities are assigned. In this episode, we have discussed about magnitude, intensity, their definitions and the differences. We have also seen the effects of earthquakes on terrain, underground and surface water, the built environment, that is the construction, and some of the miscellaneous effects. Now, based on these effects, on the terrain, the construction and the human being, we assign the intensities. To assign the intensity, we have the scales. In the next episode, we will discuss the individual scales. The most important scales are the MSK and the MMI, which we will discuss in the next episodes.